All right. I will post the videos from both this class and third period. So anything that I go over in that class that we don't get to in here, you're welcome to skim through that video. I would usually just like click through and see what was gone over instead of watching the whole thing. Unless you really want to. It is there at your disposal. Yes.
Are you guys coming to school tomorrow?
Am I coming to school? Yes, I will be here at school tomorrow.
What?
Because it's Tuesday and my daughter doesn't have a doctor's appointment scheduled this week. That's why I missed last Tuesday.
And if there's no school tomorrow, what's that mean?
Do you still studying?
It would mean an extra day to study for this test and one less day to study for the final exam. So, yeah, because the end of the semester is not moving. What would you guys like to look at or talk about? All these answers, by the way, will be posted in Canvas in the slide presentation after school today. Every single question on the review. Oh, speaking of, there was actually a typo on the printed version that I found in question number 1. So I want you guys to look at number 1 with me real quick, and then I'll take requests. I just remembered that somebody pointed out this typo, because it's not on my version, and I don't know why, because I thought I printed it right from here. Number 3, what it says on the board for number 3 is not what yours says. What does yours say?
For days to hours.
Yours says days to hours there. You can leave it like that, but that means that none of the options over here are correct.
No, mine says Terrence has a heart rate of 81 beats.
Not for question number 1.
You said 3.
Question number 1, this right here. I wish it was labeled A, B, C, D, but then what would we call the other options, you know? So that's why it's, I suppose we could use like the Roman numeral, lowercase I, but no thank you.
I have a question to ask you, but...
All right, give me just one moment. Yours says, come on, go back. Why are you not going back? I just love it when things misbehave. It's great. Did it disappear? How did that? Okay. Somehow it literally just is now gone. Let's see if I can get it up. Sorry, read yours to me one more time. Ooh, you know what I can do? I know what I can do here. What does yours say? Minutes to hours, right? All right. There we go. Yours says days to hours. Yeah, these are the right answers for number 1. No, I pulled this up on purpose because my thing just literally erased that whole page, and I don't know how it did it.
What's 24D?
That is how you convert days to hours. Because think about it. How many hours are there in 2 days? 48. What did you just do in your head? 24 times 2.
Isn't it supposed to be even?
24 times 2, if this is days. E on yours has D over 24, right? Go look at option E on your page.
Mm-hmm.
It says D divided by 24, right?
Mm-hmm.
It should be H divided by 24.
Oh, that's not a big typo.
No, but you do need to change it. That is how you convert hours to days. You would take the number of hours, like 72 hours.
Days to hours or hours to days?
Hours to days. 72. That's why I said you need to change it.
Oh.
Divided by 24. If this is the number of hours, that would come out to be how many days? What is 72 divided by 24? Anybody? 3. So that would be 3 days. 72 hours is the same as 3 days. Yes, this is problem number 1.
So what hours or days is part of what? The E?
Part E should be H divided by 24, and that is how you convert hours to days. Yours is a misprint. It has D over 24. Yep. I just wanted to make sure, like I said, I found that typo, and it's actually a big enough deal that I wanted to talk about it, because it will throw you off. This, though, is why I always put units with things. And it's why I always write things down as proportions, so that I know whether I've got it the right way. I know whether I should be multiplying or dividing, because what I want to cancel should always be on opposite sides of a fraction. All right, Kyla, you had your hand up before I remembered that there was this typo here. Number 4? Absolutely. Let's go do number 4. A whooping crane's neck is 1/3 of its body length. James is 6'2". If his neck had the same ratio as a crane's, how long would his neck be? What is this 1/3 when it says his neck is 1/3 of his body length? What does that mean? Divide his height by 3, yes. So he has this neck to body ratio of 1:3, where this is neck and this is body. And so, yeah, we are going to take James's height and divide it by 3 to figure out how big his neck would be. How tall is James? 6'2". How many units is that?
Inches.
It's feet and inches, isn't it?
Yeah.
James is 6 feet 2 inches. And even though we don't write it down usually, we know that that means together, right? 6 feet plus another 2 inches. If I want to take his height and divide it by 3, I can't be working in 2 different units. It's got to be 1 unit, either all in feet or all in inches. What do you guys want to do? Do you want it all in feet or all in inches? Inches sounds good. How do I take the 6 feet then and change it into inches?
12 times 3.
Yes. 6 feet. I always write down my proportions, because that's how I keep myself from making the mistakes of, wait, I was supposed to divide and I really multiplied. What's the relationship between feet and inches again? 12 inches is a foot. Where do I put the 12 inches part? In the numerator. 12 inches is equivalent to 1 foot. How do I multiply fractions? Yes, we're going to cancel feet, and I multiply straight across, top to top.
Can you kind of like, I'm sorry, what is it?
74, 70 something.
72, and then we are going to add it to that 2 inches from before, so the total would be 74, yes. So this is 72 inches. So when we put these two together, James is 74 inches. All right, so I have his height. That's his whole body, right?
Mm-hmm. I'm going to divide that by 1/3, right?
We're not dividing it by 1/3, we're dividing it by 3. There's actually a huge difference between those two things. I'm not just being picky about words. 74 inches is his body. I'm going to multiply that by the crane's proportion. We want to figure out how big James's neck would be, right? So I want the body length to cancel. So 3 for the body, 1 for the neck. That's this ratio here, the proportion. When I write it like that, I can see that even body and body is going to cancel, right? Just the same way feet and feet canceled earlier. I always want to make sure that I'm setting up my proportions correctly. And then I multiply straight across. This is over 1. And so that's how I know that I need to do 74 inches divided by 3 to get the neck. What is 74 divided by 3? Yep. 24.67, 24.7 inch neck. 24 inches is how big? 2 feet. So right about 2 feet and an inch. Crazy. I think 2 feet. His neck would be about this big. That seems kind of ridiculous, right? Having a neck that long. I mean, I know there's some places where they stretch necks, but I don't think they stretch them that long. There's a second part to this question. Second part to the question is this last sentence over here. We're going to pretend that we didn't know that James was 6'2". What we do know is that a normal human neck is about 6 inches. Normal human neck, 6 inches. If that's all we knew,
That's a neck size?
yeah, like if you measure from here to here,
Oh.
it's about 6 inches for most people. Give or take a little, I'm sure.
Yeah.
But if you average it out, it's about half a foot from here to here. Remember, you're not like necessarily going here. You're measuring from here to here.
I live at a 10-inch neck.
If James was built like a crane and his neck was a normal human neck size, 6 inches, that means he would be how tall? How would we use this to figure out
Add
if
6 inches to his height.
add 6 inches to his height?
Multiply by 4. I don't know.
Multiply by what? What's the relationship on a crane again?
Oh, no.
Tell me how you did that. 6 times 3. Tell me why you multiplied by 3. It's 1/3 of his body. We want to figure out how big his body would be, right? So if I multiply by 3, that's the body proportion, over 1, that's the neck proportion. This is a 6-inch neck. I'd cancel these things out. Multiply straight across. Down in my denominator, I just have 1 times 1, right? So I'm multiplying the 6 and the 3 together, and we would get 18-inch body. 1.5 feet.
So both of them are
It really should have had a part A, part B,
the
because there's two separate questions here. It's saying if you know James is 6'2", if he was built like a crane, like when we did these, how big would his neck be?
That's too much money for this one.
Well, like I said, it's technically two problems here.
Oh, you did. I didn't even say that part, right?
Yep, that's okay. This was our part A right here. And this was our part B. So here's B. And here's A.
He's only a foot and 6 inches?
If he had a normal human-sized neck, but he had the proportions of a crane, yeah, James would be about this big. Not very tall. About the size of an actual crane, right? A little bit shorter. I think cranes are a little bit taller. What else do you guys want to talk about or look at? Number 7. And you said which one?
5.
Since we're right here, we'll do 5, and then we'll go do number 7 right afterwards. Absolutely. Number 5. I was baking cookies and accidentally grabbed the wrong measuring cup. Instead of putting in 2 1-cup scoops of flour and 1 egg, so that's the proper proportion, what did I do? What did I do instead? I put in 2 2/3 of a cup scoops, and what else? And 2 eggs. That's a problem. If I've already put in the 2 eggs and the flour, can I get part of the egg back out again? Not really. It's not salvageable at that point, but I don't want to throw it away. I don't want to be wasteful. I'd like to save my cookies. So we need to figure out how much flour and or eggs we need to add. We're going to make more cookies, but we're going to get it back in the right balance here. So I'm going to do a double number line. Do you guys remember doing Nana's chocolate milk? Oh no, Nana's going to kill me. All right, so we've got flour and eggs. So I'm going to have one number line for my flour. And I'm going to have another number line for my eggs. So I'll do flour up on top. And I'll do eggs down on the bottom. I know that the perfect proportion, the perfect ratio, is how much flour to how many eggs. 2 cups flour to 1 egg. Since we've already added another egg, I'm going to put this at about the halfway point. So 2 cups of flour and 1 egg. This is perfect. We have 2 eggs in there, right? Which means we need how much flour total to get it back in balance? I need 4 cups total. This would be perfect. So this is where I need to get it to. We've put in what already? I know the 2 eggs part. We got this. What do we have flour-wise? 4/3, because we did 2/3 and then another 2/3, right? So I'm going to take this 2 cups of flour up on top, and I'm going to break it into pieces so that I can see what we've already put in, so that I know how much we need to add. Halfway right here, how many cups would that be? That would be 1 cup. I want to take that 1 cup and break it into how many pieces? 3 pieces. 1, 2, 3. So 1/3, 2/3, 3/3. I'm going to do that to each cup. So this is 1 plus 2/3, or sorry, 1 plus 1/3. This would be 1 plus 2/3. Over here, I know there's a 3-cup mark somewhere here. So this would be 2 plus 1/3, 2 plus 2/3, and then over here, 3 plus 1/3, 3 plus 2/3. I feel like I need a different color, and I don't know what color to use. Let's try this one. All right. So I put in this much in my first scoop. And then I put in this much in my second scoop, right? So I still need all of this to get it up to the proper proportion, right? How many whole cups do I need to add? 2 whole cups. Do I need to add part of a cup?
Yes.
How much?
Half.
Half a cup?
Yeah.
None of my little markings are half cup marks.
Wait. 2/3.
2/3, yes. I need to add,
Is the test just like this?
it's very similar. 2 2/3, oops, I wrote 3/3. 2 2/3 cups of flour. That would get it right proportionally if I add that much. That would be the same as the double batch of cookies then, right? All right. Number 7 was the next one that we had a question about, right? Okay. The diagram shown is a scaled down version of an airplane. The highest point of the airplane sits at the ordered pair 2.5, 29.1. The scale for the diagram is 1 unit equals 17.3 feet. When we're looking at an ordered pair like this, what part comes first, the X or the Y? X comes first, and then Y. Which way does X measure, left and right or up and down?
Up and down.
X measures up and down?
Oh, left and right.
Left and right. X measures left to right. And Y measures up and down. If the question I'm being asked is how tall, am I looking at both the X and the Y? Which part do I want for how tall? I want Y. What would the question be if they wanted X? How wide? How wide would mean I need that X, right? Technically, this would get me only to the halfway point on the wide. How tall is the airplane in feet? Well, I know the Y part of this ordered pair is 29.1 units, right? How can I take that information and convert it into feet? Yes. We're going to multiply. We know that 1 unit is equal to 17.3 feet. So I'm going to set up my proportion with 17.3 feet in the numerator and 1 unit in the denominator. So units cancels with units, multiply top to top. bottom to bottom. And what do we get when we multiply those together? You said 503.4? What kind of units do we need with that? Feet. I've usually in the past been very lenient about units on stuff, but this whole unit here has been about conversion. So you have to include, like, if there's feet or inches or miles or kilometers or anything like that, it has to be part of your answer here.
What if we forget the square?
I'll probably be a little bit more forgiving there as long as you have the other units. I'll be more forgiving on a squared thing. How would I take that and then answer part B? Times 12. 503.4 feet. The relationship between feet and inches is, yes, there's 12 inches in 1 foot. So now my feet cancel. And what would we get? 6041?
Yeah.
6041, and you said point 16?
Squared.
It's not going to be squared.
Inches.
It would be inches. 504.3 times 12. 0.6. Yeah. I got 605.6. Oh, wait, nope. It's because I transposed 2 numbers. I put it in my calculator wrong. 6040.8 is what I got when I did that. Can somebody double check me on that?
Mm-hmm.
Is that correct?
Yeah.
Okay. What units does that get? Inches. What else would you guys like to look at? Yes, ma'am. Number 9, sure. Oh, you really want to look at part C?
Yeah.
Yeah. We have to do part B to do part C. So yeah, let's just do number 9 all the way through. For part A, Paris and London are 214 miles apart. Cool. I want to know how far away these things are on the map. I know I don't have a map that is big enough to actually put 214 miles in between 2 things. I have to be able to hold it in my hands, right? How can I take 214 miles and convert it into the units that this map uses? What are the units that the map uses? Inches. What relationship between miles and inches does this map have? 1.5 inches equals 50 miles. Where would I put the 1.5 inches? Top. I put the 50 miles on the bottom so that what can happen? So that it can cancel. Miles will cancel with miles. This gets a denominator of 1. We multiply top to top and bottom to bottom. So in my denominator, I still have a 50 down there right now. What do I get in the numerator when I multiply 214 by 1.5? How much? 321. So how do I finish answering this question then? Yes. And what do you get? 6.42. Same basic idea on part B, and then we'll use our answer from part B to do part C. What do I know in part B? In real life? No. They're more than 2 feet apart in real life. But on the map, this is obviously a large map if there's 2 feet between them. Probably like a big wall map. How can I take 26.43 inches and figure out the real life distance? What's the relationship between inches and miles on this map? What do we know about the relationship on this map between inches and miles? 1.5 inches is the same thing as 50 miles. Okay, so I'm going to multiply. I'm going to use that conversion factor. Where do I put the inches? At the bottom this time. And I put 50 miles up on top. So that what can happen? So that the inches can cancel. So we're going to multiply top to top and bottom to bottom. So I still have a 1.5 down in the denominator. I do 26.43 times 50. And I got 1321.5. What are the units that I still have? Miles. And then to get my final answer, I do what? Divide by 1.5, and we get what? 881, I'm sorry, I didn't hear your units.
Oh,
No? Miles. 881 miles apart. All right, part C. Holly and Destiny are driving from Rome to Paris. That sounds like a fun trip. How far are they going to be driving?
11.5.
How far? Not how long, how far? 881 miles. We just figured that out. They only have 11 and a half hours to make it there. Woo-hoo. If they do not stop, what speed will they need to travel to make it there in time? How do we calculate speed, at least here in the US? Miles per hour. Speed is measured in miles per hour. That's a proportion, right? When I see miles per hour, which thing are they telling me when I see miles per hour? Which thing would be in the numerator? Miles divided by the number of hours. Do we know how many miles they need to go? 881 miles. Do we know how long they have to do it in? 11.5 hours. So if I do 881 divided by 11.5, doesn't come out to be a whole number. We're going to round it to a whole number. But what does it come out to be? 76.60 miles per hour. So we should probably round this to what? 77 miles per hour. Because when you drive down the road now, I know between between Rome and Paris, they're not going to have speed limit signs in miles per hour. But just as much as I know that anywhere they have posted speed limits, they're not going to have decimals on there. They're going to have them in whole numbers. When I'm in my car, even with the digital speedometer, they don't give me decimals there. What else would you guys like to look at? We got about 5 minutes. That's 1 or 2 questions, depending.
6.
Number 6? Sure. I was testing out a soda recipe in my soda stream before making a big bottle to put in the fridge. I used a 1/2 ounce of syrup to 8 ounces of soda water in my glass, and I thought it tasted good. So I liked it. So 1/2 ounce of syrup in proportion with 8 ounces of soda water. That made me happy. When I made the large bottle, I used 5 ounces of syrup and 40 ounces of soda water. And my friend said it tasted weird. Do the 2 servings have the same ratio? What does ratio mean? Give me other words that mean the same thing as ratio. I can think of one that starts with a P, one that starts with an F. Fraction. This is a proportion or a fraction. So I want to know, if I set these up as fractions, are they the same? So the one that I liked had 1/2 ounce of syrup to 8 ounces of soda water. It doesn't matter which one I put in my numerator and which one I put in my denominator, as long as I set the other proportion up exactly the same. So if I wanted to compare this to the large bottle that I made, what should go in my numerator there? Five ounces, because I put 5 ounces of syrup in there. To how much soda water? 40 ounces of soda water. When I look at 5 and 40, I know something that goes into both of those. What goes into both of those? 5. How could I reduce that then? Yeah, 1/8, right? This would be the same as 1 ounce syrup to 8 ounces soda water. I'm not going to write the words up because it's taking up a lot of space. Is that the same as over here? No. Which one has more syrup in it? So I had the glass that I made as a test, and I liked it. That's what I have written up here in purple. 1/2 ounce of syrup to 8 ounces of water. When I made the big one, what's the proportion? 1 whole ounce of syrup to 8 ounces of water. Which one has more syrup? The big one. The big one has twice as much syrup in it. They're not in the same proportion. What do you think that would taste like if it has twice as much syrup? Yeah, the big one's too sweet. That's why it tastes funny. Like it's twice as sweet as the other one. All right. I will post all of the answers in Canvas along with all of my work. I did do some different questions in third period than we did in here. So, like I said, I'll post both videos. You guys are welcome to use these. I am available tonight by Canvas if you have any other questions for me. Okay? Awesome.